Hey everyone, and welcome. Today we are going to tackle something absolutely critical for anyone working in the cloud, and it's a topic that trips up so many people. We're talking about high availability versus disaster recovery. Getting this wrong isn't just a small technical error. It can literally put a business at risk.
I have heard this so many times. I hear it constantly from really smart, really experienced engineers. And you can see why, right? It just sounds right. Hey, we spread our app across multiple availability zones in AWS. We're good to go. We're resilient. Is that confidence really earned? Really? Does spreading your services across a couple of data centers in the same city truly make you disaster-proof? Well, today, we're going to put that exact statement under the microscope and bust a huge myth about what resilience really means in the cloud.
All right, let's just dive right in. The core of this whole issue is what I like to call the great resilience myth. It's this super common belief that if you have a great high availability setup, then, you've automatically got disaster recovery covered. But that's a huge mistake. It comes from mixing up two completely different ideas of protection. The easiest way to get this straight is with a simple analogy. Think of high availability, or HA, like the spare tire you have in the trunk of your car. It's there for a common, pretty small problem, a flat tire. You pull over, you swap it out, and you're back on the road in a few minutes. Disaster recovery, or DR, that's for when your car is totaled in a massive wreck. A spare tire is completely useless. What you need is an entirely different plan, like having a whole new car waiting for you back at home.
Okay, so with that car analogy in our back pocket, let's get a little more formal. To really build systems that can withstand anything, we have to be super clear about what these words, availability and recovery, actually mean. So high availability is all about surviving failures inside a single location, like one AWS region. It's your first line of defense against the everyday stuff. A server dies, a database instance flakes out, or heck, even a whole data center, which AWS calls an availability zone, goes dark. The goal here is pure automation, aiming for zero or as close to zero downtime as possible. Disaster recovery, though, is playing a totally different ballgame. This is not about one piece of your system failing. This is about the entire location being gone. We're talking about a massive natural disaster, a region-wide power outage, or some crazy software bug that cascades and takes down an entire AWS region. Here, your goal isn't zero downtime. Your goal is survival. It's about getting the business back on its feet, period. So let's look at this side by side because this is really where it clicks. Look at the scope. HA is intra-region. It all happens within one single geographic area. DR is inter-region. It has to span across multiple, physically separate areas. And the goal is totally different. HA is all about that continuous, uninterrupted service. DR is about recovering the whole business after a massive outage. And you can see how this all translates directly into the tools we pick from the toolbox. For high availability, you're using services that work within a region, right? Things like an application load balancer spreading traffic across AZs, or a multi-AZ database. But for disaster recovery, you have to think bigger. Your tools have to be inter-region, like using Route 53 for DNS failover to a different continent, or cross-region replicas to have your data safely copied somewhere far, far away. Okay, theory is great and all, but let's make this super real. We're going to run a little simulation here. We'll look at two totally different kinds of failures and see exactly how these strategies play out in a real architecture. So let's start with a problem that happens all the time in the cloud. An entire availability zone in, say, the US East 1 region just went poof, it's offline. Maybe a fiber cut, maybe a power problem, who knows? What happens to our fancy multi-AZ application? Okay, so the second that AZ1 goes dark, what happens? Well, our application load balancer's health checks start failing instantly. It knows those servers are gone, so automatically, without any human intervention, it just stops sending traffic there. Every single user request gets seamlessly rerouted to the healthy servers that are just humming along in AZ2. And what's the result for our users? Nothing. It's perfect. The system stays up, customers don't notice a thing, there's no downtime. This is high availability doing its job perfectly. It handled that localized failure like a champ, a total win. But now, let's up the stakes, a lot. We're not talking about one data center anymore. A catastrophic event has just knocked the entire US East 1 region completely off the map. It's just gone. What happens now to our so-called disaster-proof multi-AZ application? Well, first things first, our HA setup is now 100% useless. All its pieces and all its AZs are sitting in the same dark region. But this is exactly where our disaster recovery plan snaps into action. Our global DNS, Route 53, sees that the health checks in US East 1 are failing. That triggers our failover policy, and it automatically flips the DNS records to point all of our users to our backup environment, which has been waiting patiently over in the US West 2 region.
And the result here? The business is saved. Now, look, it wasn't invisible like the HA failover. There was probably a little bit of downtime while the DNS change spread around the world. We might have even lost a couple minutes of data that hadn't been replicated yet. But at the end of the day, the business is back online. It's operating. That is what a successful DR looks like. And that brings us to the single most important lesson from all of this. I want you to let this one really sink in. When a whole region fails, your beautiful, complicated, expensive, multi-AZ high-availability architecture is nothing more than multiple points of failure sitting inside the same giant crater. It gives you absolutely zero protection. Okay, so the myth is officially busted. Now what? As architects, what are we supposed to do? How do we design for this harsh reality where we have to handle both the small stumbles and the giant catastrophic falls? Well, it really boils down to just a few core ideas. First, and most importantly, never ever confuse HA and DR again. Second, you have to talk to the business and define two magic numbers. Your RTO, the recovery time objective, which means how fast do we need to be back up, and your RPO, the recovery point objective, or how much data can we afford to lose. Those two metrics will drive every decision you make. And last but not least, test your DR plan. You have to. An untested DR plan is not a plan. It's a wish. It's a prayer. So I'm going to leave you with this one question to take back to your team. The next time you're looking at your architecture diagrams, I want you to ask, honestly, is this thing we've built designed to survive a small failure, or is it truly built to survive a catastrophe? Because knowing that difference and planning for both is what separates a pretty good architect from a truly great one.